Legends of LEDs, it's Prof G, and in this lesson we'll show you how to add an LED strip to a Raspberry Pi Pico or Pico W. In earlier lessons in CircuitPython School, we used the Circuit Playground Bluefruit with a NeoPixel strip, but you can connect just about any CircuitPython board to a NeoPixel strip. My students also use the Raspberry Pi Pico W, so in this lesson we'll learn how to connect a NeoPixel strip to that board, and we'll learn how to modify code from earlier lessons to work with this setup. The concepts in this lesson will be the same regardless of whether you use a Pico board or a Pico W. And if you're starting here because you don't have a Circuit Playground Bluefruit, after what you learn about the Pico and Pico W in this lesson, you should have enough knowledge so that you can go back to the CircuitPython School lessons that use NeoPixels and make simple modifications to the lesson code so that you can follow along there too. So let's learn big! So here are two Raspberry Pi Pico boards. This is the Pico W. The W stands for wireless, and at the time of this lesson, it supports Wi-Fi. In the future, it should also support Bluetooth. Now, I've soldered header pins onto this board so that I can easily insert it into a breadboard for simple wiring. Now, this board here is the Raspberry Pi Pico, not W, so it's not wireless. You can see the Pico W has a big silver square, which is the wireless chip. The plain Pico has the Raspberry Pi logo in the place where the W has this chip. And I haven't soldered the header pins on this board. In all of my tutorials, you'll see me using a Pico W. If there's anything that I do with the W that doesn't apply to the Pico, I'll say that explicitly. The wiring and code I'm about to show you should work the same, regardless of whether you're using a Pico or a Pico W. Now, both of these boards are microcontrollers. They don't run the full Raspberry Pi operating system like the numbered Raspberry Pi boards, the Pi 0, the Pi 3, or the Pi 4. So if you see any projects for full Raspberry Pi computers, they don't work with Pico boards. The Pico boards are microcontrollers. They don't run the Raspberry Pi operating system. Instead, these guys will run one program at a time, and we've been saving that code with the name code.py in the examples that we create in CircuitPython School. Now, in the same way our Circuit Playground had circular pads for wiring up components, the pins on a board like this serve the same role. The pads on the Circuit Playground work great with alligator clips. Pins are much more useful for wiring using a breadboard, this guy here. Now, the pin or pad names were easy to read on the CPB, but the pin names in the Pico are harder to read. You'll find them on the back of the Pico, and the writing is really small. For someone like me that has eyesight so bad that I can't drive, this is not very good. Now, when working with a Pico, I find it really helpful to open a browser and look at a diagram showing the pin names. Just search online for Raspberry Pi Pico pinouts. You can search for Pico W if you're using that board, and if you compare the Pico W and the Pico, you'll find that the layout of pins and the pin names is pretty much identical. So let's wire up a NeoPixel strip to our Pico board. This is the same 30 light NeoPixel strip that I'd used in earlier CircuitPython School lessons, and in the earlier lessons with the CPB, we learned that an LED strip like this needs to connect to power, signal, and ground. On this strip, power is red, signal is white, and ground is black. Now, if we look at the diagram of the Pico board, we can see that we've got a choice of 8 ground pins. They're all identical. They all show up in black on this diagram. Now, when I work, I'm going to orient my board so that the USB port is to the right, and I could use any of these ground pins, but I'm going to choose this one on the top of the USB board. This will be the third pin in from the right. This is a good spot since it's opposite the side where the power pins are. You never want to mix up your power and your ground pins. That could cause problems. Now for power, our projects, unless I explicitly say so, are all going to be powered through the USB connection on the Pico board. We're either going to connect our Pico board directly to our computer's USB port, or we'll use a standard mobile phone wall power supply like this one for an iPhone, or we'll use a candy bar style mobile phone battery for mobile projects. So most of the components that we use are going to be powered off of the V-bus pin here. See it in red? It's the first pin on the right on the bottom row of pins. This connects directly to the power that's applied through the USB power port. Now, if we were to work for a project that had, say, lots of NeoPixel lights, several light strips together, then we might need an additional power supply for those lights, but if we ever create projects like that, I'll cover this issue specifically in those learning videos. Now, as for signal, I can use any of the green pins. Now, for the Raspberry Pi Pico boards, these pins are all numbered GP. The GP stands for General Purpose Input or Output. And in CircuitPython with this board, I'm going to refer to those pins using the prefix GP. Now, when we were coding along with the Circuit Playground, we referred to our pads with the prefix A followed by a number. When writing CircuitPython code for the Pico boards, we're going to refer to any of our board locations with GP in the pin number. And for this NeoPixel connection, I'm going to choose pin GP15. It's in the top row at the far left. Since I'm choosing this pin, whenever I set things up on my board, I'm going to use a location board.gp15 in CircuitPython. So this is the wiring diagram. I've put the pinout diagram down below so that you can see the names of the pins. So the ground that I'm using is the third from the top right, signal is the top left, power is the bottom right. With the actual project, I've got alligator clips on the end of my NeoPixel strip, so I've attached pin wires to each of these clips. Then I plug in my ground wire to the ground pin up here, the power wire down here to my V-bus pin, and my signal wire to GP15. In a future lesson, I'll talk more about breadboards and different wiring schemes that we can use, but for now, let's just get things to work. And one quick side note, you also want to make sure that the metal connections that are exposed here don't touch each other. Make sure those are separated out. If they do touch, your electronics won't be damaged, but you might find that your lights stop lighting up properly. Sometimes you might even have to restart your code. If you run into problems, always make sure that the metal components of the different wires aren't touching each other. So now that we've got everything wired and we know how to refer to our signal pin in our code, the rest is easy. We'll set up our NeoPixels the same way we did in our earlier lessons, but when working with the Pico board with the strip wired up to GP15, we're going to pass our location in as board.gp15. And since I have a NeoPixel strip with 30 lights, I'll pass in a 30 as the second parameter. Now my students already know how to code a NeoPixel strip. If this is new to you, be sure to check out the lessons earlier in CircuitPython School. So over in Moo, I'm going to code up a quick test program. I'll put in a comment that says RGB flash with Raspberry Pi Pico. I'm going to import board, NeoPixel, and time. Let's create our strip, and we'll set this equal to NeoPixel. That's our library, .NeoPixel, the class. We pass in two parameters here, board.gp15. GP15 is the pin location on our Raspberry Pi Pico board that we've used as the signal pin. That's the pin that's connected to the white wire on our NeoPixel strip. The strip has 30 LEDs, so we pass in a 30 as our second parameter. Then I'll create the three colors. Red equals in between parens 255, 0, 0. Green equals between parens 0, 255, and 0. And blue is 0, 0, 255. Then we'll flash each of these three colors for 3 seconds at a time. So I'll create a while true loop, and beneath that I'll say strip.fill passing in red, time.sleep passing in 3.0, strip.fill passing in green, time.sleep passing in 3.0, and strip.fill passing in blue with time.sleep passing in 3.0. Then I'll click the serial button to open the serial console, click on save, make sure I'm saving it to my CircuitPy volume. That's my Raspberry Pi Pico. And as our code runs, we see it flash for red for 3 seconds, green for 3 seconds, and blue for 3 seconds. So congratulations, CircuitPythonista. We've got a NeoPixel strip working on a Raspberry Pi Pico. And next, let me show you how reusable the code we wrote in our earlier lessons is. So for students who completed the Adafruit LED animations lesson, let's use that code on our Pico board. Even though we wrote it for a Circuit Playground Bluefruit, all we need to do is change one line. So I'm going to close my serial console and close my code.py tab, and I'll click on the load button, head to my desktop, and go into my CircuitPython School folder. And here's the code I wrote in that earlier lesson on the Adafruit LED animations. Now this program also has code that works with the internal NeoPixels on the CPB. In our lessons, we accessed those from a variable that we called pixels. Now we don't have any built-in NeoPixels on our Pico W board, so I'm going to highlight these 3 lines here where we set up the pixels and delete those. Then, and this is the most important part, to get all of the code that we wrote that worked with the strip on the Circuit Playground Bluefruit, all we need to do to get it to work on the Pico W is change this one line here. We set our strip pin to point to board.A1 because that's the pad that we clipped our signal wire to when working with the CPB. But for the Pico W, we have the strip signal pin attached to board.gp15. So we'll change this to board.gp15, and that's pretty much it. Everything else is going to be deleting the internal NeoPixels that we don't have on the Pico W. So each of these animation lines here has a pixels version above the strip version. The strip version ends in _strip. So I'm going to go through all of these animations one by one and delete the version above the strip version. I don't want anything in here that's still setting stuff up on pixels. Notice that I'm not adding any code here. I'm just deleting code. I'm also going to delete this first animation sequence, but I'm going to keep animations _strip animation sequence. I want that. Then down here in the while true loop, I'm going to click on the second line, that's animations.animate, and I'm going to Command K to comment that out. Although I really should delete this because I just got rid of the animation sequence. Then I'll double click on my tab, find and select my CircuitPy volume. That's my Pico board. I'm going to save over the existing code.py file here, open the serial console, and will you look at that? All of the animations we wrote earlier with the Circuit Playground Bluefruit now work on the Pico W. The only thing we changed in this code was the setup of the strip object. We changed the signal pin from board.A1 that we used on the CPB to board.gp15, which is what we're using on the Pico W. Now I'm also going to save the code that I just modified, so I'm going to double click on the code.py tab up here. And on my desktop is where I've got my CircuitPython School folder. I'm going to save this file as Pico W Adafruit LED Animations. And now I've got a nice example of how to set things up on the Pico W. Now, if you haven't gone through the earlier CircuitPython School videos and want to, for any of the videos on NeoPixels, you just have to set up the NeoPixel strip using this code here, substituting board.gp15 in for anything that refers to board.a1. And you can even go through any of the lessons that refer to the internal NeoPixels named pixels, just set up the strip like you see down here, and anytime in the code you see the word pixels, replace that with the word strip. That's it. But regardless, stay tuned because we have lots more Raspberry Pi Pico and Pico W lessons to come. Now go make something awesome.